Hello, algebra students. Mr. Lawrence here, and today we are going to be learning about solving absolute value inequalities. Now, some of you don't even know what absolute value is, okay? Now, look, absolute value will be a symbol that looks kind of like this, and there'll be a number or a variable or a combination of both inside of there. But before we actually get to doing these problems and how to solve them, we have to have a good definition of absolute value. All right, and the definition we're going to use in this class will be, hold on, I got a sneeze coming on, achoo! The distance from zero on a number line. Yes, the distance from zero on a number line. Okay, did you get that? The distance from zero on a number line. So, for example, if I want to know the absolute value of 3, you see this? This is not a 131. This is the absolute value of 3. My 3 looks kind of strange. Let me rewrite it. Sorry about that. This is the absolute value of 3. Okay? The absolute value of 3. I'm asking you how many spaces on a number line is 3 away from 0. Now, I'm going to modify this definition later on, change that word 0 to some center, but for right now, 0 is going to work really well. So, let's see here. If I'm at 3, how many spaces am I away from 0? Well, I'm 3 spaces away, so the absolute value of 3 is 3. Okay? Now, the absolute value of negative 4. Well, how many spaces away from 0 is negative 4? Let's see, 1, 2, 3, 4. There would be negative 4 there. How many spaces am I away from 0? And hopefully you're not saying negative 4, because distances are never negative. Did you get that? Distances are never negative. The absolute value of negative 4 is 4. Now, some of you have to hold the bus right there. Hold the bus. Some of you just made up your own rule. You said, oh, inside you said, oh, I get it. When I the absolute value, just make it positive. No, 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 no. Never say that. It's not true. Because that will handicap you. That will keep you from being able to do problems that have variables in them. So the important thing is to remember that the absolute value is the distance from 0 on a number line. And again, I'll change that word 0 to a center, to literally a center later on. But for right now, it's going to work out very good. So let's try this one here. The absolute value of x equals 2. What's x? Now, some of you are going, 2! But I don't agree with you. You see, to figure out the absolute value of x equals 2, to solve for x, the first thing we have to do is translate the absolute value part. And so what we're going to do is we're going to consider all the points, all the possible values where x is 2 units away from 0 on a number line. But then we're going to have to consider the ones that are in 2 in the negative direction from 0 on a number line. I mean, if you think about it, 2 is here, right? How many spaces is 2 away from 0? Well, silly, it's 2 spaces away. But negative 2 is also 2 spaces away. So the absolute value of x equals 2, what does x equal? Well, x equals 2. Or x equals negative 2. Yeah, there's 2 solutions to it, right? Okay, let's see how to do this one. So I'm going to relocate it over here. Looks like I left my equal sign behind, but that's okay. And I have to translate it. I have to translate the absolute value of x plus 1 equals 4. So this is really easy to do. I have 2 pieces to it, always 2 pieces. Okay, I'm going to have x plus 1 is going to equal 4, or I'm going to have x plus 1 equals negative 4. Yeah, see, I'm going to need to get each number, one on the positive side of 0 and one on the negative side of 0. Now, when I change that to the center, it'll still make sense. It'll be the positive side of the center and one on the negative side of the center. Okay, so I'm going to solve for x in both equations. and I'm going to get x equals 3. All right, here I'm going to solve for x, but I'm going to get x equals -5. And there's my solution. Now some of you are thinking, wait a minute, Mr. Lawrence, on a number line, 3 isn't 4 spaces away from 0. And you're absolutely right, it's not. But remember, I was going to change that definition. Okay, if I look at a number line, where are you? There we go. If I look at a number line, okay, and I look at 3 right here, and -5 would be about here, right? So -4, -3, -2, -1, 0, 1, 2. Let me go 4 spaces to the left. 1, 2, 3, 4. Right? Now let me go from -5, 4 spaces to the right. 1, 2, 3, 4. And look at that. I end up at the same place. Where did I end up? -1. So the center of this graph, of this problem, is actually -1. And I knew that ahead of time because what makes that equal to 0? X plus 1 equals 0. Well, if I solve for x, I get x equals -1. So my center is actually at -1. So I was asking what two numbers, or what numbers, are a distance of 4 spaces away from -1. That's what that one is asking me to do. Okay? Now, when we get to inequalities like this, it's a little bit different. Okay? It's a little bit different. Whoa, what are you doing, pen? You're acting strange. It's not terribly different, but the trick is you have to know how to read this symbol and how to read that symbol. Excuse me. And I'm going to mispronounce them. I'm going to remember that this is a less than. Not a less than, a less than. This is going to be an and statement, and you'll see what I mean in a minute. This one here is going to be a great, or it's going to be an or statement. So I'm going to come over here, and I'm going to solve this absolute value inequality. First thing I do is break it up into 2 pieces. I translate it. So I'm going to go 2x minus 5, and that is going to be less than 13. And since this is a less than symbol, I'm going to write and 2x minus 5 is greater than -13. I flip the symbol and change the sign. I'm going to solve each piece. I'm going to add 5 here and add 5 there. Add 5 everywhere. 2x is going to be less than 18. Dividing by 2 will tell me that x is less than 9. And I'm going to come over here and solve this. Add 5 to both sides. I'll get 2x is greater than -8. Divided by 2 will tell me that x is greater than -4. Well, let's put this on a number line and see what it looks like. Okay, let me give myself a little bit of room here. So I'm going to have this number line. I'm going to show -4, and I'm going to show 9. All right, my points are open points because 9 is not a solution to this inequality, and neither is -4, so they're both open. Now, where are the numbers that are less than 9 and greater than -4? Aren't they in between? Aren't they in between? Greater than -4 and less than 9. And there you go. There's your solution set right there. All those numbers in between there. By the way, ands will almost always look like this. Maybe like that. Okay? There's an exception, but usually ands look like one of those. All right, let's try this one here. It's going to be done the same exact way. I'm going to translate it. And I'm going to break it up into two pieces, right? I'm going to do 5x plus 3 is greater than or equal to 15. Now this is a great or, so I'm going to say or 5x plus 3 less than or equal to negative 15. I flip the symbol and change the sign. Do both things. All right, so I go and solve for x. I'm going to subtract 3 from both sides. All right, so I'm going to get 5x greater than or equal to 12, or subtract 3. Oh, I'm not done. I'm sorry. I have to divide by 5. And I'm going to go mixed number on this simply because it'll make more sense to me on a number line. So that'll be what? 2 2/5. Okay, so I subtract 3 over here, going back to the problem. I'm going to get 5x less than or equal to negative 18. I'm going to divide by 5, divide by 5. X is going to be less than or equal to negative 3 3/5. Okay, now remember, this is an or. Okay, let's go on a number line and see what this looks like. So get my number line out. Okay, and I'm going to have to show negative 3 3/5. I'm going to show positive 2 2/5, right? These will be closed points because the 2 2/5 and the negative 3 3/5 are solutions to the inequality, right? Okay, now I need all the numbers greater than or equal to 2 2/5. Well, they would be to the right of 2 2/5. Okay, here I need all the numbers less than or equal to negative 3 3/5. Well, those would be to the left. And there's my graph. There's my solution set. My solution set includes anything from negative 3 3/5 towards negative infinity. And it also includes 2 2/5 all the way towards positive infinity. Nothing in between here fits. What does that mean? Well, hold on. Let's take a look at the original inequality, the absolute value inequality. What was it? 5, absolute value of 5, x, absolute value of 5x plus 3, and that was going to be greater than or equal to 15. Now, I'm telling you that if you pick any number in the shaded area, you will get a true statement. I'm also saying that if you pick any number not in the shaded region, you'll get a false statement. You know, I love to pick 0. 0 makes my life so much easier. So I'm going to substitute 0 in. So I'm going to get 5 times 0 plus 3, and the absolute value greater than or equal to 15. If this is a true statement, and everything I've told you is wrong, 5 times 0 plus 3 is 3. So the absolute value of 3 greater than or equal to 15. Well, what's the absolute value of 3? How many spaces from 0 on a number line is it? Well, it's 3 spaces. So the absolute value of 3 is 3. Is 3 greater than or equal to 15? Nope. And I'm so glad I got a false statement because 0 is not in the shaded region. Let's pick a number like, say, 5. If I plug 5 in here, I'm going to get 25. 25 plus 3 is 28, so I'm going to get the absolute value of 28. Is that greater than or equal to 15? Well, the absolute value of 28 is 28, and that is greater than or equal to 15. So you see I got a true statement over here. If I come on this side and pick a number like negative 10, I'll also get a true statement. I'll let you verify that on your own. Okay, if we want to scroll back up and look at the previous one, okay, the problem said the absolute value of 2x minus 5, and that has to be less than 13 to be in our solution set. Any number I pick in the middle there better give me a true statement. any number outside this shaded area will give me a false statement. Let's plug in 0 because it's right in the middle there. 2 times 0 is 0. 0 minus 5 is -5. So I have the absolute value of -5 is less than 13. Well, what's the absolute value of -5? Well, it's +5, of course, because how many spaces are -5 from 0 on a number line? And 5 is less than 13. So you see how this works? It's so easy to check our work. All right, so tomorrow in class, we're going to get a little practice with this in your homework over the weekend. But let's recap, okay? First off, we know that we have less than or equal to. And then there's also great or than or equal to. And I'm saying those wrong on purpose to help you remember the ones on the left here are ands, and statements. And ands often look like this. And we'll talk about the exceptions at a later date, okay? We're not going to say they always look like that, but much of the time they do. These are or statements. And or statements graph something like this. Okay, and again, there are some unusual exceptions, and we will talk about those at a later date. Okay, so there's that, and there's that, right? Those are supposed to be arrowheads. They're not looking very good. All right, so let's go through the steps. The first thing we do is translate the absolute value. And so I write down 2x plus 7 greater than or equal to 11. It's an or statement. And then over here I write 2x plus 7, and that's less than or equal to -11. All right, so I'm going to solve each one for x. So I'm going to subtract 7 and subtract 7. I'll get 2x greater than or equal to 4. Divide by 2, divide by 2. X is going to be greater than or equal to 2. Or, same thing over here. Subtract 7, subtract 7. Going to get 2x is less than or equal to -18. Divide by 2, divide by 2. And I'm going to be getting x is less than or equal to -9. All right. So, got to put -9 on, got to put 2 on. By the way, that I mentioned how ands and ors look. I'm not going to use that to graph. I might use that to check really quick. It's more a guidance. Like, I really want to understand what I'm doing. So I'm going to use closed points because 2 is a solution to the set. I need a closed point at 2. -9 is a solution to the set, is in the solution set. And so I'm going to say x is greater than or equal to 2. Well, give me a number that makes that true. How about 5? So the numbers greater than or equal to 2 are to the right of 2 on a number line. And over here, I need a number that's less than or equal to 9. How about -10, which would be to the left of -9 on the number line. And I do my little check, and I see the or is opening the way I expect it to. All right, that's your video. We're going to get some practice with that tomorrow. Mr. Lawrence signing off. Have a good night, everybody.